In this video, we are going to talk about distribution, mode, median, and mean. Let's first talk about the distribution. One important piece of information that a graph of a continuous data can give you is the shape of your distribution. Okay? And we usually have three different kinds of distribution. There are supposed to be more distribution, but these three are the most common and the most easy distribution we are going to see in social sciences or criminal justice or criminology. So the first one is normal distribution. A set of scores that clusters in the middle and tapers off to the left and right of the number line. The positive skew is that it has a long tail toward the positive side, a long tail toward the positive side. The negative skew, it means it has a long tail toward the negative side. So it's really wordy when we see in those definitions. So I would like to show you the pictures for easy understanding. This is the picture of normal distribution, negative skewed distribution, and the positive skewed distribution. You can see the normal distribution is that it's really look like a bell shape, and the left side is identical to the right side. Okay, so this is the positive side, this is the negative side. They are identical. It only peaks one time here. So for the negative skewed distribution, you can see it's also a bell shape, but if you put a line in the middle, it looks like the left side, the negative side, is larger than the positive side, right? And most importantly, it has a long tail toward the negative side. And if you take a look at the positive skewed, you put a line in the middle, and you will see the right side is kind of larger than the left side, right? And it has a long tail toward the positive side. Okay, those are the very basic shapes of the distribution. Now you may also see some of the distribution look like this one, or some distribution look like this one. Okay, these are all the possible distributions, but these are not really common. And most importantly, the normal distribution is always our focus in the stats. Sometimes we also look at the negative skewed and positive skewed in the very fundamental statistics. And in regarding those distribution, they have different like two peaks at the same time in the same line. It's a more higher level of the stats. So you are familiar with this age crime curve, right? If you draw a line look like this one, in the previously we talked about this line, right? And you will see that this is really a positive skewed distribution, right? Because it has a long tail toward the positive side. So if this is not so clear, but you can also see that we use the line chart to show this distribution look like, right? A positive skewed distribution. So measures of central tendency. The central tendency basically means where the data points tend to cluster. So most of the data points, where are they? The majority of the data point is where are they? Okay, so the measure of central tendency is a very basic descriptive stats. And in this PowerPoint, we just going to talk about the mode, median, and mean, the most of three common central tendency measures. So like in the normal distribution, those three are supposed to be in the middle, right, in here. And for the negative skewed, also we're looking at where the data time to collapse in the middle or somewhere. And in the positive skewed, it's also like here, is where we're trying to see the data cluster. So why this is important? The average is an excellent predictor of individual scores when the curve is normal. And the distribution of the variable plays a key in the hypothesis testing. Almost every hypothesis testing has its fundamental assumption about the distribution of the variable. If the variable does not match the distribution, then you probably need to switch to different hypothesis testing methods. Okay, and also it is important to know where the middle of the data set is located, just as we show here. And knowing where the distribution is normal skew is a benefit the criminology and criminal justice researchers. For example, when we're going to take a look at these very positive skewed example about age crime. So the pattern we found out is that lots of teenagers tend to more likely to commit some crimes or delinquent behavior than the adults. Now, this is important in the criminology and criminal justice, particularly for like the crime prevention, is that these people, the teenagers from those ages, those teenagers are the one we try to focusing on. Okay, because they are the one who actually commit disproportionately crimes than the adults. So first of all, let's talk about mode. The mode is very simple. Actually, it's a simple list of the three measures of the central tendency. It's just a very simple, it's the most frequently occurring value. Now, the one thing I want you to pay attention is the occurring value. Okay, I will show you some examples is that the value is important. It's not a variable's name, it's actually the value within the variables. The good thing about mode is that very simple. You don't have to need to do any statistical analysis or doing anything. But the weak is that it's just too simple and too superficial, and it's not really that useful. Like you don't really see lots of times in the academic papers that people talk about mode. Okay, and mode can be found with the nominal variables because nominal variable you can count them. Male and female, it's a nominal variable. How many males, how many females, you can count it. Okay, there are 5 males, 10 females, you can count it. Okay, and also mode of a categorical variable will be the label name. The mode of a continuous variable will be a number. Of course, it will be a number, but the first thing, the categorical variable's mode will be a label or the label name. This is the one I want you to pay attention to. Okay, and also the mode is a categorical label name, not the frequency itself. That's most of the time people got confused that they put down the frequency, they put down the counts, but indeed for those categorical variables, it's really the name, not the frequency. And you will see some examples in the following a couple of slides. So the first example here is what is the mode in this example? You can pause the video. Okay, the answer is 5. As you can see, how many 5 we have? 1, 2, 3, 4, 5. We have 5 fives, right? And so if you take a look at other numbers, there are not more than 5. So the 5 is the mode of this group. So what about this mode? You can pause the video. Okay, the mode is 3 and 4. Now in this case, we have 1, 2, 3, 4, 5, 6, 6, 3. We have 1, 2, 3, 4, 5, 6 fours. So 6 threes and 6 fours. So they have the same frequency, but simultaneously the same frequency is the highest frequency. So in this case, there are two modes, right? Both 3 and 4, and their frequency are both like 6. Now, if you take a look at this table, we have the reasons for traffic stops and stop reason, for example, speeding, defeat, record check, roadside check, seatbelt violation, or blah, blah, blah. Okay, and on the right side, it's the frequency of those stop reasons: speeding, vehicle defect, record check. Okay, so what is the mode? The mode is speeding. This is the one we talked about before, is that this is a categorical variable. right? This is a categorical variable that it only has names. So the thing is, for the categorical variable, the frequency is not its mode. The frequency is used to find the mode. Okay, the mode is the highest frequency. Among those frequency, the highest frequency is this 2040. So in those categorical variable, the frequency is used to find a mode. The mode is the name or the label's name, which is the speeding. Okay, so if you put the 2040 here, 2040 here, then it is wrong because this is a categorical variable. So you should put the label's name, which is a speeding here. Median. Based on the name, well, median is like, well, which something in the middle, right? Median based on the name is something in the middle. So median can be used in some rank order the data. So as long as the data or the variables name variables value can be rank ordered, then the median will show you. So the median basically talk about it's a cut point. Where the cut point is that it cuts the whole data into half. So this is the data. Okay, let's say this is the data, whole data. It cuts the data in the middle. So it gives you something that tells you that there are 50% things, cases below this line, and the 50% things, numbers, people, whatever, above this line. Okay, it's a cut point. So the thing you need to do, one, is that the median really based on a rank. Okay, so the categories or scores can always be ranked, but the categories is supposed to also needed to be rank ordered. So you have to reorder those numbers or reorder those categories so it can be in a good order. Whether from the high to low, from the low to high, you have to reorder it, okay? Re-rank it. And also we use the formula, what they call the median position. It's literally just calculate where this median is. The n is a sample size plus 1 divided by 2. And then use this number to identify the median. It's really simple. So again, I put a sentence here is when the sample size is odd, then the median will be a value in the data set, right? If it's odd, it divided, then it will be some certain, very certain number. However, when the n sample size is even, then you will see that you have some 0.5 something coming out. Okay, 0.5 something coming out. Then that will be the calculated by the average of two values. Let's take a look at some example. Now, first of all, what is the median in this group? You can pause the video. So in order to get the median for this group, we first of all, like I said, we have to re-rank it, right? We have to rank it from the lower to the higher or from the high to the low. It depends on yourself. Then the second one is that we got to calculate the median size and to see what's in the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 plus 1, that's 19 divided by 2, that's 2. I think that's 9.5. So it's around, it's the average of the number 9 and the average of the where the number 10 is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it's the average of those two numbers. So the average of 2, 5 is 5. So what is the median of the following number? Okay, again, you have to rank them from the low to the high or from the high to the low. It depends on your discretion. It doesn't really matter. So you will look at this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 plus 1 divided by 2, that's 16 divided by 2, that's the eighth. So you're looking at the eighth number, which is a median. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the median in the next one is 5. So median can be found in the ordinal data as long as it can be ordered. It cannot be used in the nominal data because nominal data cannot be ranked, cannot be ordered, right? So the median of this ordinal data is less precise than the continuous data. Okay, but still it's the median. Okay, and the first two steps in the finding median are similar in finding the median of a continuous variable when we're trying to locate the median in the ordinal data. The third step is again we're looking at it at the category or the label or the name instead of the frequency. Again here, instead of the frequency, we're looking at the name of the median. Okay, so the example here is like you can see the question asked, how often do you drive? People answer 5 different ways. Every day, a few days a week, a few days a month, a few times a year, and never. So these are the this is a categorical variables answer, right? These are categorical variable. This is a categorical variable, and the thing is you can actually rank them. I rank them this way is that from the highest often to the lowest often you drive. Every day, several days a week, several days a month, several times, several days a year, something like that, or never, right? So when you can rank them, you have the frequency here, 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 and you have total sample size. So in order to solve this issue, what is a median? We need to calculate the median position. The median position is where 772.5 here. Now this is a little bit trick part, is that we talk about already give you the answer is a few days a week. So what we think about is that if we ask people to standing here one by one, one by one, one by one, there are lots of people standing here one by one, right? And the thing is, we ask them to standing here based on how often do they drive. If they drive every day, almost every day, they stand in this way. If they never drive, they stand in this way. So there is order. Okay, so we have like around here, we have 751 people standing here. I don't care whether their height is, their weight is, but if they drive every day, they are standing here. We also, after them, we have another 217 people here, right? They drive a few days a week. Then we have 82 people here, 37 people here, whatever. So the position is 772. So this is 751. So it go past this one. This is 217. So it must be somewhere in this group. The 772 must be somewhere among those guys in this 217 group. And now again, 217 is a frequency. It's not the median of this categorical variable. The median is the value or the label's name of this categorical variable. That's why the answer is that the median in this case is a few days a week. So the good thing about the median is that I use more information than the mode. We talk about the mode is just too simple, right? And also median can be used with ordinal variables and not really sensitive to the extreme outliers. So even if you have extreme outliers like long here, but still we are looking at something in the middle, right? You having a few people long positive or having a few people super negative doesn't really impact something in the middle, which is a good. But the bad side about the median is that it does not really use all the data. Okay, and it cannot be used in the statistical computations we will talk about in the following PowerPoints. The thing is that the median, well, it look like better than the mode. right? In terms of using more data points, in terms of interpretation, it seems better. The mean. The mean is maybe the people also know what the mean is. It means average, right? The average of the data set. And in stats, we usually use this one, X with a little bar here. Now, typically I call it X bar. I don't know what other people call it, but usually I call it X bar. So typically we use the X bar in the stats to represent the mean of a data set. Okay, so um, unlike the median, the calculation of the mean requires use every score in the data set. And also the mean can only be used in the continuous variable, whether it's a ratio variable or whether it is an interval variable, that we can only use this in the continuous variable. Cannot be used in the categorical variable, that including nominal or ordinal variable. Okay. The formula to calculate the mean is very easy. People already know this, right? So you know that the average means average. So you add everything together divided by the total sample size. The sigma here indicates the sum of the x. So you add every x together divided by the how many x's you have, right? The total sample size. Now, this is the most common formula. We also have a really uncommon formula is using the group data. The group data we showed in the previous PowerPoint is that sometimes like you have so many similar numbers that it's harder to display everyone, so you group them, right? In the group data, it just use the frequency of the group and the value of the group. You multiply by them and divide it by the total sample size. The fundamental idea is the same, is that for the top, you need to calculate everything. Everything is a sum of everything in this data and developed by the sample size. Okay, so it's not a big difference. It's just you have to calculate everything. You have to put everything together. So some simple example is like among those 5 numbers, what is the mean? So what you do is really simple. You add those 5 numbers together divided by what? 5, right? 5 is the sample size, so you will get 24.98. Now, here, this is the group data, right? Now the question is, what is the mean? So you can see the question is the number received 0 to 20. Some of the numbers are not here, right? On the right side is frequency. So basically, whatever this data is, this tells us there are 17 people receive 0. There are 8 people receive 1. There are 4 people receive 2. 1 people receive 4. Okay, and the total there are 36 people in this sample. So the common mistake people do is that one, they add numbers received together divided by 1, 2, 3, 4, 5, 6, 7, 8 divided by 8. It doesn't really make sense. It's not the mean. Second, what the common mistake people make is they add all the frequency together divided by 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9 divided by 9, which basically not meaningful as well, right? So the thing is that in order to solve this question, we have to use the second formula, which is used for the group value. Okay, we have to calculate the each group's sum and add them together to calculate the total sum, the total value, then divided by the total sample size. So the formula will be like 17 multiplied by 0, 8 multiplied by 1, 4 multiplied by 2, 1 multiplied by 4, blah, 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 blah. And you get all the things together, then divided by the total sample size. Then you will get an average is 2.17. That's the correct way to calculate the group data. Okay. So for the mean is that it has a good thing or bad thing. Again, there is no perfect in stats, right? So the mean is really sensitive to extreme value. Imagine, okay, imagine we have a number received like 20000, and we have 1 people here. Now this will drag the whole mean 2.17 to a very big one, simply because in this formula we have to add another very large number like 20,000. Okay, so it's really it's kind of sensitive to the extreme values, outliers. But the good thing, again, good thing is we mentioned this before, it uses the entire data set. Okay. Bad side is use extreme to the extreme, sensitive to the extreme value. So the good example is like Bill Gates. People know Bill Gates, right? So the Bill Gates has a saving maybe about 86 billion in his bank account. And for me, I usually have less than 10 grand in my bank account. So the thing is like I'm represents like a common people, right, in the US. Maybe you guys have more than I do in my saving account, but me really represents a common. But Bill Gates is like a super rich. So the thing here is like if we average us, me, and Bill Gates, the average, this 10,000 can be just, mm, I don't need it. So it's like really it's 86 billion divided by 2, so which is about 43 billion. So if me and Bill Gates have the average, or take a look at the mean of me and Bill Gates, we are, oh, I'm going to be super rich, like 43 billion, right? So it's another example, like it's really sensitive to the extreme value. Now here, the funny thing is the extreme value really it is defined by the direction you make. So for Bill Gates, I am the extreme number. I am the extreme small number, right? But for me, on my perspective, in my perspective, Bill Gates is an extreme large number. So we both are extreme numbers to each other, right? Um, so the central tendency, mode, median, mean, and the relationship between the distribution is that we always often use the median and the mean in a distribution. So it will give us some information about what the distribution look like. So in normal distributions, mean and the median will almost be equal because, well, you see the normal, right? The middle is sort of where the mean is, and also is sort of where the median is, and even it's sort of where the mode is, right? In the positive skew distribution, the means greater than the medians. In the negative distribution, the medians greater than their means. Okay, this is not easy to remember, but if I show you the picture here, this is a more easy way to remember. For example, for all the curve, since it peaks one time, so the mode is always at the peak. The mode is always at the peak, right? The difference is between the where the mean and the median. So for example, like for the positive skewed, because we have this long positive drag or tail, drag the whole data as mean into a little bit right side, right? So where the median is here, when the mean is here, so in the positive skewed, the mean is larger than the median. Now, on the other side, in the negative skewed, so the median is still here, but since we have a long negative tail, it drags the data moving, the average moving to the negative side. So where the mean is less than the median. Okay, always remember on the left side is a negative, right side is a positive, same, right? Now for the normal distribution, or they call symmetrical distribution, everything is supposed to be in the middle, right? We just mentioned this before. So this picture or the graph is easy to remember the relationship between the median and the mean, especially the median and the mean and in different types of distributions. So a little bit summary here is like can we use those things in different variables? So we have categorical variable, right? Nominal and ordinal. We have continuous variable, interval, and ratio. So the mode can be used in everyone. It's the highest frequency, right? So it can be used in everyone. The median can only be used in the variable that can be ranked. Median can only be used in the variables that can be ranked. So starting from ordinal, interval, ratio, those three can be ranked. Nominal, no. Okay, but the mean is only used for the continuous variables. Okay, categorical variable, it doesn't really mean anything in the categorical variable. For example, me and my wife, a male and a female. What's the mean of us? Male plus female divided by 2. That's like, well, it has no meaning, right? So it only works in the continuous variables here. Okay, so later when you're going to decide, okay, what I'm looking at, or which one I'm going to use to describe the central tendons, is that, well, if it's a continuous variable, you can basically use all the three. If it's an ordinal variable, you can use the mode and the median. But if it's only a nominal variable, then you probably only use the mode to describe the distribution. That's it.